Tomorrow is a hectic day for me. In the morning itself, I have 3 hours of travel. Have to read and comment on a technical project document, which will take 2 hours. And I also have to attend 2 conference calls of 30 minutes each. I'm struggling to figure how can I do 6 hours of work in 3 hours. Train journey, which is going to be last for 3 hours. Then he has to attend a conference call, then work on the document, then again continue the conference call. John, why don't you multitask while you take your train? You can take your calls and work on the document while you travel. So train journey starts lasts till 12 p.m. starts from 9 a.m. You can attend the conference call between 9 and 10, 9 and 9:30. Then work on the document between 9:30 and 11:30, and finally between 11:30 and 12 you can attend a conference call. In programming also, we can overlap tasks to save time, and it is termed as concurrency. When you execute one task after another, it is called sequential execution, and when you overlap them, it's called concurrent execution. Simple. For example, if function 1 takes input from the user, then function 1 will be waiting till the user enters the input. In the meantime, function 2 can be executed. Function 1 executed, then function 1 waits for input. After receiving input, it continues execution. And after this process, function 2 executes. This is a sequential process. When it comes to concurrent, function 1 executed. When it waits for the function 1 of the input, in the meantime function 2 executes. Then function 2 execution completed, as well as function 1 also receives inputs. Then function 1 continues. So it saves a lot of time and resource. There are different mechanisms through which concurrency can be achieved in programs. These are some. Multitasking. Unit of concurrency is the process which is like a task or a job. Concurrency is achieved by interleaving execution of different tasks. Multithreading. Unit of concurrency is a thread which is smaller or lightweight compared to process. One process can have multiple threads. This allows for a finer level of concurrency during interleaved execution. Multiprocessing. Here we would have multiple CPUs executing concurrently. So processes or threads can be assigned to different available CPUs and be concurrently executed, achieving concurrency. We'll be focusing on multithreading in this course. Look at this example. This is the code without concurrency. Execute the code in Eclipse and observe the time taken. Tryit2 has to wait till tryit1 completes the execution. The output of tryit is shown only after tryit1 runs. So look at this. Tryit1 is called. It's waiting for the input till we enter the input. It has to wait. So only then the next process executes. Done is from tryit2, and enter your name. It waits for the input, then it processes. So this is what it happens. It is a sequential processing method. When you use a threading, from threading import thread. So we tryit1 and tryit2. We create a thread, assign it to. We create a thread and assign it to thread 1. We are creating a thread 1 for tryit function 1. Then we start the thread. Then again we create another thread for tryit2. Then we start the thread. Then we join the threads. So what happens when the function 1 waits for the input, or if it takes some more time, parallelly tryit2 also executed. It does not wait for the function 1 to get completed. Look at the second example. The moment you run the program, by the time it waits for the function 1 execution, waits for the input, we got the output for second function. Done. It is being printed here. So after you enter your name, then it gives a result. This is the concept of multithreading. This is it. Complete the code given in the starter code pane based on the comments given in it. So this is code without multithreading. We'll have to convert it as a multithreading process. So we've done the necessary changes in the program. We've written the code to add some between this range. We also written a function 2 to add, to read 5 numbers and add some of it. Now we have created threads. Target 1 function 1 and target is function 2. We have started a thread 1 and thread 2. Then we using join. We join both threads together. So whenever it finds a time, look at this output very carefully. You will understand. Look at this. Enter a number. By the time it waits for the input, it finished the process for another function. So we enter number 45 we enter number 90, 09, 1, 2, 45. Together it says sum from function 2 is 147. So it did not wait for the function 1 to get over or function 2 to get over, right? So whenever it finds the time, it completes another function and finished up and give us the result. This is the concept of multithreading.